Alright guys, so welcome to our fourth installment of the Toxicity and Water Pollution Unit. Okay, so this is lecture number 4, and in this particular lecture we will be talking about how to differentiate between point source and non-point source pollution. We'll talk about potential water pollution sources, a little bit about laws/policies pertaining to water pollution. One thing that is not in the textbook because it's much more recent than the published date is the Flint, Michigan water crisis, which, by the way, there is this sort of weird little trend I've noticed in AP free response questions. It seems as though some sort of environmental related thing that's been in the news, 2 years later, it often pops up in as one of the FRQs on the AP test. So there's a chance we might see something about the Flint, Michigan water crisis as one of your 4 FRQs on the actual AP test coming up here in less than a month. All right, and then of course the accompanying pages from the textbook are pages 517 through 524. And as always, I highly recommend that you follow up your notes from this lecture with the associated reading. All right, let's move into this. So looking at water quality today. So first of all, differentiating between point source and non-point source. Point source pollution refers to water pollution that can be traced back to a specific origin. So let's say, for example, we have a leaky sewage pipe, right? That's leaking water into like a lake or a pond or a stream. Right, we can trace that sewage pollution back to a single point or a single source. That's what we call point source pollution. Okay, so a pipe, sewage, or a particular ditch or something like that would be our point source for that pollution. Non-point source pollution, which is most of the water pollution that we're dealing with, is from it comes from a large area. So trace amounts from a large area that maybe drain into a specific region. So most of our agricultural pollution, for example, fertilizer runoff, pesticide runoff from all kinds of fields, runoff from our roads and parking lots and stuff like that, carry trace amounts of pollutants, but they all end up maybe in the same body of water, enough so that we call it pollution, but it's traced back to a specific origin, right? It's what we call non-point source in that case. All right. So we'd say it's diffuse, but its cumulative effect can be pretty large. All right. So one thing, again, make sure we can differentiate between point source and non-point source pollution. One's not necessarily worse than the other, although point source pollution is much easier to fix because we can go back to that single location and deal with it, whereas non-point source would require fixing large areas of land. All right. Pretty important fact to know, in the U.S. at least, water pollution, the number one source of water pollution is agriculture. And again, that's referring to fertilizer and pesticide runoff from crop fields. It's animal waste and byproducts and stuff like that gets into water. So the animal waste and plant residues cause a high biological oxygen demand, meaning there's a large amount of causes that eutrophication process that we talked about earlier in the unit. Okay, chemical pesticides can leach into groundwater. Some of those things can cause, some of those issues we talked about back in the toxicity chapter. Some of them are endocrine disruptors and so on. And darn near every stream and river in the United States has at least some pollution from agriculture. Okay, now the types of pollution that we deal with on a municipal level, so from parking lots and driveways and streets, are what we see in this particular drain. So what you guys may or may not understand is our storm drains. So the drains that drain the streets when they're not clogged up with leaves, by the way, those do not go directly to a sewage treatment plant. They drain off into for the most part, one of the Mill Creek, but other neighboring creeks as well, right? So those are not going to our sewage treatment plant and then getting treated with chemicals to leach out, lead and stuff like that. It's most of it just going straight into our streams. Okay, and so from your yard, for example, if your mom and dad fertilize, or if you fertilize, shouldn't say that's your mom or dad necessarily. There's a big heavy rainstorm. Some of that runoff can end up in our streams and increase biological oxygen demand with that nutrient enrichment process. Organic waste from the dog droppings and stuff like that. From your driveway, you got used motor oil. Sometimes antifreeze or coolant leaks on the driveway. Ethylene glycol, which is what they use in your antifreeze, by the way, is nasty stuff. Okay, copper from auto brake lining, and zinc from weathering strips and stuff like that on your house. All these things can work their way into our streams through our storm drains. All right. So again, when we talk about agricultural pollution, we're talking about fertilizer and pesticide runoff or animal waste. And we're talking about municipal water pollution. We're talking sometimes yard fertilizer, but a lot of it's like used motor oil or coolant or trace metals from building materials and stuff like that. All right. Industrial. One of our biggest water polluters is actually the food industry again, so tracing that back sort of to agriculture, but food processing in this case. So the food waste, gets put out in to waste pools, right? And those greatly increase the biological oxygen demand because those food wastes do have to decompose. Bacteria consume that food waste to decompose it, but use up a lot of the oxygen in the process. Our paper mills, so you guys have been by Boise Cascade and smelled that god-awful smell. That smell, by the way, is not the steam you see coming out of the coolant tower or the cooling towers. That is just water vapor. That's steam. What you're smelling actually are those ponds, those big pools of water with the fountains in them. And you're smelling the byproducts of the gases and decomposition of the materials in those ponds. And the reason those fountains are there are actually to increase the amount of oxygen circulated in that water to help speed up that decomposition process. So it smells god-awful, but actually by the time the water actually leaves that place, it's pretty darn clean. They do a darn good job there at Boise Cascade of cleaning up their water before it gets out into the Columbia or Snake River. Right? So again, most industries, at least in our developed world, recover their toxins before they're released out into a stream. And that is thanks to the Clean Water Act, one of those big three environmental legislation pieces. Again, the big three would be the Endangered Species Act we've talked about, the Clean Water Act, and then of course we have our Clean Air Act that we'll talk about in the next chapter. Okay, but the Clean Water Act is one of those big three, and they set industry standards for what they call the maximum contaminant levels for how much they're allowed to allow out into the waterways and so on. All right. So the book has a nice little graphic for kind of the ways in which water can get into, pollution can get into our groundwater. And there's multiple sources. So you've got essentially percolation, right? So water gets polluted at the surface for the most part, right? And as that water percolates through, not all of that pollution is removed, and it works its way down into our aquifers. Our confined aquifers, right, are much less likely to become polluted, although in some cases they're actually injecting hazardous wastes into our deep aquifers to get them off the surface, away from our streams and rivers and stuff like that. But leaky septic tanks, leaky sewers, settling ponds outside industrial plants, those can seep groundwater pollution in there. Nitrates and pesticides can seep into the ground from our agricultural fields. Nitrates can cause a condition called methemoglobinemia, often referred to as blue baby syndrome. And so the nitrates get in the bloodstream and it cuts off your body's ability to carry oxygen. Young children and infants are more susceptible than adults. But essentially, the babies are breathing, but they're not carrying oxygen, and they start to turn blue, which is why it's called blue baby syndrome. That's methemoglobinemia is what that's called. So in 1972, the Clean Water Act set federal standards or limitations on our point source discharge. So we're usually talking about industry in that case. So sets the MCL, which which is our maximum contaminant level for various hazardous chemicals that can get out into our water. And so the EPA is the agency in charge with monitoring that process, right? So all pollutant discharges into surface water must be permitted by the EPA and also monitored by the EPA. Okay. Now, in 1974, the Safe Drinking Water came into effect. Now, what you have to understand is the Clean Water Act sets maximum contaminant levels. So there's different levels of water quality. There could be water that's perfectly fine in terms of being able to use for irrigation, for example, or probably not going to be very toxic to, let's say, fish or aquatic organisms, at least not overly concerningly so. The Safe Drinking Water Act sets much higher standards for our drinking water than what would be safe for, like, discharge. Okay? So the EPA designates maximum contaminant levels also for our drinking water based on toxicity and ED50 levels, right? And that maximum contaminant level is set way, way, way below that threshold level. The idea is not to get it right up to that threshold level because, of course, our contaminant levels can fluctuate over time, right? So they set the maximum contaminant level well below the threshold level just so we're well within that margin of safety. Okay? So the Safe Drinking Water Act, not the same thing as the Clean Water Act, much higher standards when it comes to our drinking water as far as how much of a contaminant can be in the water. All right? Which, just kind of an FYI, Dick Cheney, so you guys might be a little young, but he was the vice president for George W. Bush. And right at the beginning of the onset of hydraulic fracturing, Dick Cheney put in kind of a backdoor bill as he was the vice president so that the hydraulic fracturing process does not have to abide by the Safe Drinking Water Act restrictions. Kind of an interesting little backdoor maneuver there. Anyways, so the Safe Drinking Water Act as it applies to the case of Flint, Michigan. So again, the Flint, Michigan water crisis is not in your textbooks. You're going to have to pay extra close attention because there's a pretty good chance you'll see something about this on the AP test, or at least there's a chance. I shouldn't say a high chance. But anyways, so in Flint, Michigan, as many of you know, we are talking about lead, right, whose chemical symbol is Pb. Pb stands for plumbum, by the way, which is the Latin name for lead, which, interesting, if you think about the word plumbing and plumbum, that's why it was originally called plumbing, because they used to make pipes out of lead, or plumbum. All right? And so in the case of Flint, Michigan, the water intake pipes, right, used to feed the city water supply are old and therefore made out of lead. Okay? So kind of historically, what happened here was Flint, Michigan was suffering from some immense budget shortfalls, okay, which led to some implementation of a budget emergency management. So they were looking for every possible way they could find to start cutting costs, right? So Flint, Michigan, by the way, is a very, very depressed community outside of Detroit, Michigan. There are a high percentage of the population is below that poverty line. All right, so they're not raking in very much revenue in the way of property taxes and so on. All right, so big budget shortfall. They implement this budget emergency management, and one of the decisions made was to switch from the Detroit water to the Flint River, where they didn't have to pay the city of Detroit for the water services. They were just pulling the water out of the Flint River. Okay, as a way to cut costs. Now, I'm going to assume that they didn't really anticipate what would happen as a result of that, because the Flint River, because of its pH, is 15 times more corrosive than the water that came out of, I think it was Lake Michigan, I believe. So Detroit, with a city water supply, came out of Lake Michigan. The Flint River has a pH well below that of the Lake Michigan, and was therefore 15 times more corrosive. All right. Now, because of the higher corrosivity of the water, that allowed it to leach more of that out of the pipes than the Lake Michigan water would have. All right. Now, one of the things the emergency management didn't do, and this is probably because they were budget experts and not environmental scientists or chemists, and that's probably the biggest blunder they made, was they did this switch without consulting the experts in the field of water quality, especially when it comes to safe drinking water. All right, so because they prioritized budgetary constraints and didn't go through the proper channels, they did not need, or they didn't know that they needed to add these anti-corrosive agents to the Flint River. All right, so they didn't add that, and as a result, the older lead pipes began leaching lead due to the increased corrosivity, and they started noticing higher lead levels, right? People were actually getting chunks of lead actually coming out because the pipes were getting so corroded. People started doing some independent lead tests, which led to some actual university folks coming in, and they found between 104 to 13,200 parts per billion, depending on where they were in the city and where they were drawing water from. Now, what does that mean in context? The maximum contaminant level is 15. All right, so we're looking at our lowest levels in Flint, Michigan. After switching water, they were still 7 times higher than the maximum contaminant level set by the EPA, right? And in some cases, more than 100 times higher than the maximum contaminant level. Okay, now, so we have this excessive amount of lead leaching into the waterway. Okay, when you get up above 5,000, we're talking that has to go to like a special waste site at the hazardous waste facility, right? Above 5,000 parts per billion is considered hazardous waste, and some households drinking almost 3 times that amount in their water. All right. So what's the problem with lead? Right. Well, particularly developmentally. So when we're talking about children, it leads to cognitive impairment. So what we have is children, as they are growing and supposed to be developing into adults, their brains do not develop correctly, right? So they end up falling farther and farther behind their peers because they're not developing. They don't develop the reading and the writing and the arithmetic and the critical thinking skills that their peers would develop, right? Sometimes it results in delayed puberty, can lead to heart and kidney impairment and nerve damage in some cases. All right. So lead can actually be a neurotoxin. Now, what I want you to consider again, so this is more of a social justice issue at this point. So we're talking about a severely depressed community, right? A high percentage of the people below that poverty line, right? They had some immense budget shortfalls. They implemented emergency management. They made this switch to the Flint River thinking they were doing a good thing for the community. I'm assuming that, right? But they did not consult with chemists and environmental scientists to make sure that was going to be a safe decision based on the fact that they had these old lead pipes. All right, so enormous blunder on their part. Okay, but we also have to consider now, what are the long-term impacts of that, right? So one thing I want you to understand is this is still not resolved. Still to this day, they have not fully resolved this issue, and in fact, they're shipping in essentially these big bottled water for people to drink. Now, they could probably use it to shower, for example, and to irrigate and to clean with. It can't be used for drinking or cooking, right? So they're bringing in these big water coolers for people who are getting these and stuff for the drinking and cooking and so on. Okay, they've actually just removed funding for that, by the way. But they can't just go in and replace these lead pipes without causing more lead to get into the water supply. It's just a big problem for them. All right, but here we're going to end up, because of especially our cognitive impairment issues, we have these people that are already from a depressed community. Their children are going to suffer, at least some of them, from cognitive impairment. And it's going to be next to impossible for many of them to lift themselves out of poverty. And on top of that, the special education services that are going to have to be dedicated to this in a severely depressed community. The way this is going to play out is it's sad. It's just sad. And all because of this budget emergency management, people looking for reasons to cut costs. And so one of those things, as a potential voter, and I want you guys to think, this is not a partisan issue. This is something that we have to consider, is the budget, the bottom line dollar. Should that really outweigh the health and well-being of the people that live in an area? Okay, in many cases it does, and we have legislation in place to be sure that it does. So, for example, the Dick Cheney bill that put hydraulic fracturing as exempt from the safe drinking water status, that's choosing profits and money over the health and well-being potentially of the people that live there, right? And both sides of the aisle are guilty of that, and it's something I want you as voters to consider as you advance through this class, future voters, I should say, and think about those things, right? There's some social implications, and I want you guys thinking about that as we proceed here. Anyways, I'm getting on my soapbox. I'm going to shut up, and I just carried just the 21 minutes. So I'm going to let you guys call it quits for today. All right, make sure you guys follow up with that reading. Peace.